Yo, 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 yo. Hey, everybody. We're getting into Module 8. This is the first video, 8.1. We're going to solve systems of linear equations. Okay, so this is something totally new, and let's get to it. So a system of equations is when you have a set of two or more equations that have the same variables. So we're going to look at systems of two equations, and they're going to have the variables predominantly y and x. So it's when we have two equations together, that might look like y equals 3x plus 2, and we might even have y equals 4x minus 7. This would be a system of equations with y and x. Now, when we're solving a system of equations with these two equations, we are looking for a set of values, or an x and a y, an ordered pair, that is true for both of the equations. So we're looking at a single combination of x and y that would make this equation true and this equation true. Okay, so really what it is that the point, if we notice this system that I wrote, this is an equation of a line, this is an equation of a line, it's what point is on both of these lines. So let me get into that right now. So I think the best way to talk about this is to show an example. So here I have a system of equations. The first equation is y equals negative x plus 4 and y equals 3x. So what I'm going to do is I'm going to graph both of these lines. I'm going to graph this top one here in red. So y equals negative x plus 4. So with graphing, I always start from my y-intercept, 1, 2, 3, 4. And then I use my slope. Well, my slope's negative x, but negative x is the same thing as negative 1, which is negative 1 over 1. So I'm going to go down 1 over 1 because it's a negative slope. So this is that line right there. So all of these points are combinations of x and y that would make this equation true. So like if I took the point, this point right here is 1, this is the ordered pair of 1, 3, because x is 1, y is 3. If I plug that in here, so when x is 1 and y is 3, and I plug it into this equation, so what I did, I replaced this x with 1, I replace this y with 3 because that's a point that's on this line. It's a true statement because I get 3 equals 3. The left side and the right side are equal to each other. So x's and y, the x and y represent points on this line. So I have a bunch of ordered pairs. These are all points on the line. So that's why I graphed it. And then I can draw my line through those points. I kind of missed, but you get the idea. Now what I'm going to do is I'm going to take the second equation and I'm going to graph the second equation on the exact same coordinate plane. So I'll do this one in purple. So the y-intercept is 0 because there is no y-intercept. So that means I'm going to start here at the origin at 0. And now I'm going to use my slope, which is 3 over 1. Well, that means I'm going to go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. Now if we look, this line right here has these different points, but they both have the same point right here at 1, 3. That was a coincidence that I picked the point 1, 3. I actually didn't know that. That's kind of funny. But they both have this point 1, 3. The point 1, 3 is on this line, and it's on the other line. That means 1, 3 is a solution of this equation, and 1, 3 is a solution of this equation. So that means that the only solution to this system of equations is the point x equals 1 and y equals 3. Because if I plug in 1 for x here, that's 3 times 1, that's 3, y equals 3. Okay? And if I do the same thing here, y equals 3. So the ordered pair, so we write our solution like either 1, 3, or I write it as an ordered pair as x is 1, y is 3. These both mean the exact same thing, and that is the solution to this system of equations. So I just graph both lines. Where those lines cross, the point that's on both lines, that's the solution to the system. So that's why it's so important to know how to graph and how to graph accurately. Okay, so here's another one. Now this one, I have my first line, this is a system, and I have my second one. Now this second one right here, what I need to do is it's not in slope-intercept form, but we can make it in slope-intercept form. If we notice this is 3 times stuff in parentheses, we can just do distributive property and put it in slope-intercept form. So that's y equals 3x, 3 times x, and then 3 times negative 1 is negative 3. Now if we notice here, the top equation is y equals 3x minus 3. The bottom equation, I simplified it to also y equals 3x minus 3. These are the exact same equation. So if I graphed both of them, I would start at negative 3. I would go up 3 over 1, up 3 over 1, and there's my line, right? But they're both the exact same line. So what I would do if I actually graphed them both separately, I would end up just drawing the same line twice. They would overlap. Well, what that means when we have a system that's the same line like that, that means that there are infinite solutions. That means that every single point that's on this line would be an equation for every single point for the second one as well. So this line goes on forever, so there's an infinite amount of solutions. So that's also a possibility. Now let's look at a word problem here. So we have Keisha and her friends, and they're visiting a concession stand at a football game. The stand charges $2 for a hot dog and $1 for a drink. So $2 for a hot dog, $1 for a drink. Okay, we'll use X for hot dogs, Y for drinks. They buy a total of 8 items for $11. So I have to write 2 equations from this. Okay, so again, the stand charges $2 for a hot dog. So it's $2 per hot dog. I'm using X for hot dogs. So that's 2 times X. They're also charging $1 for every drink. That's 1 times Y. And what we're doing is they spend a total of $11. Okay, so they pay $2 for every hot dog, $1 for every drink. They pay a total of $11. What we also know is they bought a total of 8 items. Well, that means if I take the amount of hot dogs they bought and I add it with the amount of drinks they bought, it's going to equal 8, because the amount of hot dogs plus the amount of drinks is equal to 8. Here is my system of equations. Okay, so here's my system. So now what I have to do is I have to graph these in order to solve. Well, the problem with graphing these is they're not in slope-intercept form. So that's why we got to change them to slope-intercept form. So we know slope-intercept form is y equals mx plus b. So this is x plus y. I got to get the y by itself. So I just got to subtract x on both sides, because that'll go away, and I get y equals negative x plus 8. This is now in slope-intercept form. Same thing over here. I'm going to subtract 2x from both sides. That's going to go away. I don't need the 1 in front of the y. So this is going to become y equals negative 2x plus 11. And now I have a system that I can graph on a coordinate plane. And by doing this, I can now figure out how many hot dogs and drinks they bought for $11. Okay, knowing the prices. So here's what I want you guys to do. Now that we have our system set up, I want you guys to pause and graph both of these on your coordinate plane and see how you did. So pause the video, graph them both, and see if you can come up with a solution to this particular system. Okay, so here we go. Let's see here. I got negative x plus 8. And that's down 1 over 1, down 1 over 1. So here's that one. There we go. So those are all the possible combinations that they could buy. Okay. So now, oh, this is plus 11. I was wondering why that was all weird. This is plus 11. I erased it. Whoops. I hope you guys didn't mess that one up. I apologize if you messed that up. So it's plus 11. So I'm going to start here at 11. And I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And now I can see my solution because I just kind of overlapped it. So that means that they bought, we said y was drinks, they bought 5 drinks and 3 hot dogs. So 3, 5 is my solution. Okay, and we said 5 drinks, because y represents drinks, and 3 hot dogs. Well, 3 hot dogs, 3 times 2, that's 6. So they spent $6 on hot dogs and $5 on drinks, and that's $11 total. and they bought a total of 8 items. 3 plus 5 is 8. So there's my solution. 3 hot dogs, 5 drinks. Okay, last one. So we want to go bowling, play laser tag, plays us 6 total games. So we have bowling plus laser tag equals 6. So he wants to play 6 total games. He's going to play it on bowling and laser tag. So depending on how many bowling games and laser tag, any combination of that can equal 6. Okay. And then let's see here. He also knows that he sends exactly $20, and it's $2 and $4 for laser tag and $2 for bowling. So $2 for every bowling game plus $4 for every laser tag game equals a total of $20. Now, I'm going to show you a different way to graph these. Because let's think about it. If they decided to not play any laser tag games, wouldn't that mean they would have played 6 bowling games? So if I said we did 0 laser tag games, that means they would play a total of 6 bowling games. So games of bowling was 6 when laser tag was 0. They could also do it the other way. They could play 6 laser tag games and 0 bowling games, right? So I put 6 laser tag games and 0 bowling games. They could do 6 bowling games and 0 laser tag. There's my graph. I have my 2 points on my coordinate plane. So I'm done. Okay. Now thinking of the same thing, let's say they didn't play any laser tag at all. Well, if it's $2 for every bowling game, they could play, if I divide it by 2, they could play a total of 10 games of bowling. If it's $2 for every game. And they played 0 laser tag. Right? So if they want to spend all their money on bowling, they could play 10 games of bowling with $20. Well, same thing. Let's say that they decided that they wanted to, let me rewrite my equation here, only play laser tag. Well, if they only wanted to play laser tag, that means they didn't go bowling. Well, if it's $4 for every laser tag game, then that means they could play a total of, that's 4L equals 20, and they didn't do any bowling. They play a total of 5 laser tag games. So they could play 5 laser tag games or 10 bowling games. Well, there's another line. And I can see that they cross right here. Okay. So there's another line, and then I can see that they cross right there. So that means that the combination that they did choose to do, based on this information, was they did 2 games of bowling and 4 games of laser tag. And the reason why, well, 2 games of bowling at $2 each, that's a total of $4. 4 games of laser tag at $4 each, that's $16, and they spent exactly 20. So 4 plus 16 is 20. And that's 6 total games. I could have also converted this is x, this is y, so I could have had this as x and y, and I could have changed them to slope-intercept formula. It's just another way to look at it. Okay, that's it. Independent practice. I want you to graph both of these on the coordinate plane and see how it goes. Okay, thank you for watching, you guys. We'll practice this on Monday. Gordius out.